Good evening. Welcome to the very new session of Pre-Med Pro, and we are continuing with the chapter of Principles of Inheritance and Variations. In this chapter we have read up to the monohybrid cross. Today we will start from the dihybrid cross, and let me say you this chapter has nothing except this cross. Questions comes from these topics, except these topics you do not need to further study in depth from this chapter, because question never comes from this chapter except from this Mendel periodic table, except from these topics. Okay, the next chapter, the molecular basis of inheritance, is very much important because question comes from logical side, questions come from memory side, and question comes from medical side also, because in genetics that chapter carries a large weight in Neet syllabus. Okay, now today we will start from the dihybrid cross. Dihybrid cross. So in dihybrid cross we will start from a parents, a pure line, parents, pure line. Okay, that is I am taking the seed color and the seed shape. I am taking the seed color and the seed shape. Okay, and seed shape. Okay, now what happens if we take homozygous round and yellow, homozygous round yellow, and cross it with wrinkle green, and cross it with wrinkle green. This is wrinkle green. So what we will found in the cross variant? Okay, here we will find R, capital Y, and here we will find small r, small y. Now in this case this is called the gametes. These are the gametes. Here we have done cross pollination. So in that case what we will get? In the F1 generation we will get capital R, small r, capital Y, small y. What it will define? Capital R, small r, and capital Y, small y will define. This will define. This one will define round yellow, because R is round, capital R is for round, and it is dominant over small r, and capital Y is yellow, which is dominant over small y. Okay, now what we will found that it is heterozygous. Okay, now what we will get in selfing we will get capital R, capital Y, small y into capital R, capital Y, small y. This will get as gametes. What the gametes will come here? In pure line it will come at capital R, small y, capital R, capital Y, and heterozygous capital R, small y. Now another heterozygous small r, capital Y, and another is homozygous dwarf. Homozygous, it is small r, small y. Okay, these all four gametes will come here. I am highlighting the gametes. These are the gametes. Okay. Now in this case, what will come from here? Capital R, capital Y, again capital R, small y, again small r, capital Y, and small r, small y. These are all four gametes. Okay, these are all four gametes. Now what will we do? We will do dihybrid cross. In dihybrid cross, multiplication of monohybrid. Here it will in monohybrid cross in monohybrid cross, what we will get? Pure line, the pure line, the ratio will be 3:1. Phylogenetic ratio, the pure line is phylogenetic ratio will be 3:1. And here in dihybrid cross, monohybrid 3:1 into 3:1, it will come as 9:3:3:1. Okay, and again in dihybrid cross, it will generate here as 1:2:1, again 1:2:1. Okay, now the genotypic ratio will come 1:2:2:4:2:1:2:1. 1:2:1. Okay, this will come as this. Now in the next part we'll go. I have given the phenotypic as well as the genotypic ratio of the dihybrid cross. Here you will do some test mapping. Okay, test matching is for understanding only. Here question will not come, but try to understand this. Okay, if I take in number one case, if I take capital R and divide into capital Y, small y, and small y. Okay, 1:2:1. Now what will happen? Capital R is to capital Y, small y. Capital R is to capital Y, small y. Capital R here and small y. Okay, here it will happen in one case, here it will happen in two cases, here it will happen in one case. Now here what will be the phenotypic character? Here the phenotypic character will be round and yellow. Okay, because capital R stands for round and capital Y stands for yellow. Now again in next type it will happen, because the both is capital R and capital Y, again it will be round yellow. But in this case it will be round and green. Okay, round and green. Why? Because this, see, here it is small y and small y, here it is small y and small y, so it is here round and green. Okay, now here the number of genotypes 9. Okay, but number of phenotypes 4. Okay, number of genotypes 9, number of phenotypes is 4. Okay, now in the next case if we take capital R, small r is crossed with again 3 variety, capital Y, small y, and small y. Capital R, small r. Now capital Y. Here capital R, small r, capital Y, small y. Again here capital R, small y. Now here what will happen? Here it is 2 in number. Here it is 4 in number. Here it is 2 in number. Okay. So what will be its phenotypic character? Its phenotypic character will be round yellow. because capital R, small capital Y, round, yellow. Here it will also be round and yellow, but here it will be round and green. In the third case, round and green. So here we can say here genotypic ratio is 1 is to 2 is to 1 is to 2 is to 4, 2 is to 4 is to 4 is to 2 is to 1 is to 2 is to 1. Okay, here it will be this genotypic ratio. And the phenotypic ratio, what will be its phenotypic ratio? Phenotypic ratio will be phenotypic ratio will be round is to wrinkled is to wrinkled. Okay, so here it will be yellow is to green is to yellow is to green. Okay, now it will be 9 is to 3 is to 3 is to 1. Done. Again, in the third case, if we take capital Y, okay, no. In the third case, if we take small r as gamete and crossed with 3 kind of varieties, that is capital Y, and capital Y, and small y. Okay, here it will be small r, capital Y, again small r, capital Y, small y, again it will be small r, small y. Okay, here it will be 1 is to 2 is to 1. It will be wrinkled yellow. Here it will be, again it will be wrinkled and yellow, and it will be wrinkled and green. In the third case, it will be wrinkled but green. Okay, now the same ratio as above will happen also here also. Okay, now write a context. Formula, you can say it as universal formula. You can say it as universal formula. Universal number of gametes equals to 2 is to n, 2 to the power n. N equals to number of heterozygous condition. Remember this formula, it will be very much helpful in MCQs. 2 to the power n. N is the number of heterozygous condition. Okay. Next, see here. If we take, I am giving an example, capital A, capital B, small c, capital D. So here the heterozygous condition is 1 and another is 1. These two are heterozygous condition, 2 heterozygous condition. So according to the formula, number of gametes is equal to the power n. So n equals to 2. N equals to 2 here. So to the power n equals to 2 square equals to 4. Okay. So here the number of gametes will be 4. Okay. Understood? Now we come to the next part. Here we come to the next part. Zygotic combinations, oblique offsprings, oblique progeny. Zygotic condition only offspring, oblique progeny. Gametes into gametes. Universal formula from parent 1 and from parent 2. This one is from parent 1 and this one is from parent 2. So what will it happen? Capital A, small b, small c, capital D. is crossed with capital A, capital B, small b, capital C, small c, and small d, small d. So what we will get here, heterozygous condition is 1. Here also heterozygous condition, here heterozygous condition is 1, and here heterozygous condition is 2, 1, 1. Okay. So here we will get 2 to the power n is equal to 2 to the power 1 equals to 2, and here it will be 2 to the power 2 equals to 4. Okay. Understood? So zygotic combinations. So what we can say, zygotic combination is 2 here into 4. 2 into 4 equals to 8. Understood? If you have any problem in understanding, please write in the comment box. Okay. Now, these are applicable to only Mendel's cross. Okay. Now, phenotype and genotype. Phenotype and genotype. Dominant, 3 in number. Recessive, 1 in number. Okay. Now heterozygous equals to 2, and homozygous equals to 1. Now dihybrid cross F2 generation, capital R, small y, 2 into 1 equals to 2. Again, capital R, small r, capital Y, small y, here 2 into 2 equals to 4. Now, again, capital R, capital Y, 1 is to 1, 1 into 1 equals to 1, and small r, small y, 1 into 1 equals to 1. Okay. Okay. Now, here in Mendel dihybrid cross, what we will get here in Mendel dihybrid cross? What will you will get? In Mendel dihybrid cross, you will get wrinkled yellow, F2 generation, 1 into 3 equals to 3 in wrinkled yellow in F2 generation, and round yellow, here round yellow, 3 into 3 equals to 9. Okay. Round green, 3 into 1 equals to 3. Wrinkled green, 1 into 1 equals to 1. 1 into 1 equals to 1. Mendel dihybrid cross. Mendel dihybrid cross. Round yellow into wrinkled green, round yellow into wrinkled green. When their cross is done in F1 generation, their F1 generation was selved. That is F2 generation. Now in F2 generation, here number of individuals homozygous for both trait. Number of individuals homozygous for both trait equals to capital R, capital R, capital Y, capital Y. Here it is 1 into 1 equals to 1. Again capital R, small y, 1 into 1 equals to 1. Small r, capital Y, 1 into 1 equals to 1. And small r, small y, 1 into 1 equals to 1. Total 4. In B, number of individuals heterozygous for both traits. Capital R, capital Y, small y, 2 into 2 equals to 4. Number of individuals heterozygous only for first trait. Capital R, small r, and capital Y, capital Y. Capital R, small y, small y. 2 into 1, here 2 into 1, it's 2, and here it is also 2. Total equals to 4. Okay, done. And in the next case, we can say the number of round green individuals, 3 into 1 equals to 3. Okay, got it. These are the Mendelian genetics. I don't think it is too tough, but understanding it will become easy. In random cross will come in it. Okay, in random cross, frequency method, universal method, it is also called as universal method. Capital A into capital A, small a into small a, capital A into small a, capital A, small a into small a. It is a random cross. Capital A into capital A, small a. Capital A, small a into capital A. Again capital A, small a into capital A, small a. Okay, in this case, double capital A is 1, it's 100% homozygous. In this, small a equals to 1, that is 100%. Here, capital A is 1 and small a is 1. Here, capital A, small a and small a, half. Capital A, small a and capital A. So, capital A, small a, half. Capital A, half. Again, here, capital A, 1/4. Capital A, small a, 2/4, that is half. And small a is again 1/4. Okay. Till then we are completing here up to dihybrid cross. I don't think any much is important for this chapter. So if you go through the monohybrid cross and dihybrid cross, question will come from this topic only. If you read NCERT, there is long more text in the NCERT, but question will not come from that part. Okay, so I must conclude here, and I'll try to make some shorts of this chapter in the later videos. So till then, read this topic, and if you find any difficulties in understanding, do let me know in the comment box. I will definitely try to solve it. Okay, and once again I urge all of you to subscribe this channel. Please share it with your friends and please like and comment. Thank you. Good night.